1.5, parametric relations. And inverses.
Is this a hard lesson? How it works?
I mean, I don't know if hard's the right word, but weird is probably a good assessment of at least this first few problems. Find the XY pair for the given or for the value of the parameter. So they give you an x equals, so this is 5t minus 7, y equals 17 minus 3t, and then they say for t is equal to negative 2. So basically, we're finding the x and y coordinates essentially when t is negative 2. So x equals 5 times negative 2 minus 7. That's negative 10 minus 7 would be negative 17. And then do the same thing for y. Y equals 17 minus 3 times negative 2. So that would be 17 plus 6, so that's 23. So I would have the coordinate negative 17, 23. And that's your answer.
This is not weird. This is better. Yeah.
Just wait till I get to problem 6. 2 and 4 are all right. Problem 6, not so much. 4, x equals the absolute value of t plus 3. Y equals 1 over t. T equals negative 8. So x equals the absolute value of negative 8 plus 3. Well, that's the absolute value of negative 5, which is just 5. And then y is 1 over negative 8. So my point is 5 and negative 1 over 8. So yes, I would agree. Those are not difficult. So now complete the following. Find the points determined by t equals negative 3, negative 2, negative 1, 0, 1, 2, and 3. Find a direct algebraic relationship between x and y and determine whether the parametric equations determine y as a function of x. So we're going to make a table. Number 6, we've got x is equal to t plus 1 and y equals t squared minus 2. T. All right, so part A, we're going to have a table with values in it. The t values are negative 3, negative 2, negative 1, 0, 1, 2, and 3.
Did we pick these numbers or were they given to us?
They were given to us.
Okay.
How many parts are there to this question? 1, 2.
Technically speaking, there's 3, but we're only doing 2 of them. Because the last one is graphing, and we don't really need to do that. All right, so then we're going to do our x equals t plus 1. And then we've got y equals t squared minus 2t. And then we've got xy points. So basically, for each of the t values on the left, I'm going to plug those into the x and y equations respectively and fill in the table with those values. I'm not going to write out negative 3 plus 1. I'm just going to write that that's negative 2, okay, like in the box. So we're going to go down and fill them out. I would probably go through and do like all the x's and all the y's, probably the easiest, but really a personal preference. So Negative 3 plus 1 is negative 2. Negative 2 plus 1 is negative 1. Negative 1 plus 1 is 0. 0 plus 1 is 1. Are you seeing a pattern? So 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 1 is 4. Just part of why I like to work my way down instead of like going over and doing the y's. Now, the y's may or may not have the same pattern, right? Because obviously there's squares and things being multiplied. The other one was just adding 1, so that one was kind of easy. But over here for y, I've got negative 3 squared. Well, anything that's being squared is going to be positive, so that's going to be 9. And then negative and negative is going to be positive, so 9 plus 6 is 15. Plugging in negative 2, it's going to be 4, and then plus 4, so that's going to be 8. Plugging in negative 1, it's going to be 1 plus 2, so that's 3. Plugging in 0, everything is 0. Plugging. Huh?
This is where it gets weird.
Yeah. Like, this isn't hard.
Yeah.
It's really easy to plug in numbers. It's just.
I wasn't expecting the jump. So, I got
So then I've got 1 minus 2, so that's negative 1. 4 minus 4 is 0. And then 3 is 9 minus 6, so that's 3. And then we're taking these and writing them as xy pairs. So I've got negative 2, 15, negative 1, 8, 0, 3, 1, 0, 2, negative 1, 3, 0, and 4, 3. So that's the first part where it says find the points determined by the different t values. Now in the next part, they want us to solve for t, basically. That's not what the instructions say, but that's essentially what they're asking us to do, because they say to find a direct algebraic relationship between x and y and determine whether the parametric equations determine y as a function of x. So if I solve for t, that allows me to take what I have found and plug that into the other equation for t, and get something as y as a function of x. Obviously, we have to see if it's actually a function, but. So for part B, we're going to solve for t, at least in the x equation. We won't necessarily do it in the y equation, and that's just whatever equation is easier to solve it for. Typically, it's going to be the x equation is what I'm going to do. So I've got x equals t plus 1. So getting t by itself, that's going to be t equals x minus 1. So we're going to plug this in for t and y. So my y equation was t squared minus 2t. So y equals, in parentheses, x minus 1 squared minus 2 times x minus 1. I'll need to multiply all of this out. So I get, this is a perfect square trinomial, so what is that going to multiply to give me?
X squared minus 2 minus 1.
It's a perfect square trinomial. Should have 3 terms.
Minus 2x minus 2.
Plus 1.
Oh, yeah. Oops.
Perfect square trinomial is first term squared and last term squared. The middle term is the sine of the sine of this, and then it's 2 times the first term times the last term. And then over here, distribute minus 2x plus 2. So simplified, y equals x squared minus 4x plus 3. So, is this a function? Basically, our parabola's functions.
Yeah.
Yes. So, yes, y is a function of x. So, basically, parametric equations allow us to be able to graph curves or things that aren't functions. obviously the original two equations here were functions, but sometimes they're not. And so parametrizing them allows us to do this. I will also tell you I haven't seen this show up as a question on any of the AP practice yet. Not saying it couldn't, because it is one of the things that they expect us to be able to do, but I have yet to see it actually show up. So I wouldn't put like all your focus on the world on this.
Of course, the easy ones are.
Is this possible when you put it into a calculator?
Why?
Why?
Is it square?
I mean, pretty much anything can be put into the calculator. It's not needed. If I was going to graph it, yes, but I also could just graph that by hand. Okay, so jumping down. The graph of a relation is shown. Is the relation a function, and does the relation have an inverse that is a function? So number 10, they give us a graph that looks roughly something like this. So they want to know, is this a function first of all?
Yes. Cosine.
Maybe, but not necessarily.
Because they passed the vertical line test.
Yep. So yes, it is a function because of the vertical line test. So I do VLT for vertical line test. So if I go this way as I go across, there's only intersecting one time, so it is a function. But then part B says, does the relation have an inverse that is a function? To check that, we use the horizontal line test. So horizontal line test, we go this way. If it intersects more than once at any point, then it does not have an inverse. So this would be no by the horizontal line test. So I use HLT for that. If you want to write the words out, obviously you're welcome to do that, but I would, you know, probably just shorten it. 12. There's a graph that looks basically like a sideways parabola.
Ooh.
It's actually a pretty good little curve there, Drew.
Smack it still.
What's that?
All right, so is this a function?
No.
No, because of the vertical line test. Now, does this have an inverse that is a function?
Yes.
Yes.
Yes, because as I go down, it only intersects once. So yes, because of the horizontal line test. Now, you may ask, are there some that are yes to both? Absolutely. A straight line. Yeah. There's not a ton, but there are some that would be. Let's see, what's next? Find the formula for the inverse of the function. They want the domain as well. I'm not worried about that. We're not doing that part. So to find the inverse, we swap x and y, and we solve for y. So they give you f of x is equal to 2x plus 5. Well, f of x is literally just another way to write y. So if you want to write it that way instead, you can write it as y. You don't have to change it, though. You can just know that that's y. So the first thing I'm going to do is swap x and y. So that means I'm going to have x is equal to 2 times y plus 5. And it never ceases to amaze me that that's the hardest part of the whole problem for most people. It tends to be the part that gets forgotten. So we swap x and y, we get y by itself now. How do I get y by itself? Subtract 5, so I've got x minus 5 equals 2y. So y equals x minus 5 over 2. So this is the inverse of this function. Okay, this is the way that you'll see them write the symbol for inverse. Now, the beauty of an inverse is I can check it and know for 100% certainty that I am right. Does anybody remember how to do that?
Equals calculator.
Nope.
You add them together.
Nope.
You plug in the original problem into the thing.
Yep, I can actually do it either way. I can either take the inverse and plug it into x in the original, or I can take the original and plug it into x in the inverse function. Okay, it can work both ways. Some problems may ask you to verify if something is an inverse, and some may tell you to find the inverse, and then I would highly recommend you verify, because if you don't, I don't have a lot of sympathy if you get the problem wrong. It's kind of like when we factor. If you don't FOIL to check, I don't have a lot of sympathy for you. So I'm going to check this one. So we've got 2 times, we plug this in, x minus 5 over 2, and then plus 5. So 2's cancel, so now I'm left with x minus 5 plus 5, minus 5 plus 5 cancel, and I'm left with x. If you're left with an x by itself, nothing multiplied by it, nothing subtracted from it, nothing being raised to a power, then I know that I have truly found the inverse. And it would work if I plugged it in the other way as well. I would get the same thing ultimately as well. So you're not required to check them, but I strongly encourage it, because a lot of times you will find your mistake in checking it. And if you check it and you're like, I cannot figure out what I did wrong, okay, you're like, because on this next problem, it's where a lot of confusion comes. You're like, I can't figure out where I went wrong, but I know that this isn't the inverse because I checked it. I'm also not going to take off as many points because you took the time to check it and you told me I can't figure out what I did wrong. So yes, you're still going to lose points because you don't have the right inverse, but at least you've put in the effort to be like, okay, I tried and I can't figure out what I did.
So
Okay.
are we writing our answers as f negative 1 x or y?
It doesn't really matter. I know what you're trying to find. I mean, the instructions will be clear.
Okay.
16. And I can pretty much with certainty tell you that a problem like I'm about to put on the board is the kind that I'm going to give you on the quiz or the test. I'm probably not going to give you one that's this easy.
Is it big?
It's not really, but it's a fraction.
I'm putting it on the page.
So f of x
Frick, I
equals
do
x
my-
plus 3 over x minus 2.
I did it on the wrong page. Flick.
All right, so again, this is where people tend to get confused. We swap x and y. If there are multiple x's, I have to put a y every single place there was an x. People miss that all the time, so can't say it enough. So I have x is equal to y plus 3 over y minus 2. Now, I need to get y by itself. Yes.
So if there's a never mind.
Are you sure?
Yeah,
Okay.
I figured it out.
Okay. All right, so I need to get y by itself. Any suggestions where I might need to start, Zach?
Factor out a y.
How?
Divide by
Pull it
y.
out.
I cannot do that. They are being added and subtracted. I cannot.
Can I multiply by negative 3 over 2?
Huh?
Or the conjugate.
I mean, I could, but it's not going to do anything for
You
me.
want us to multiply by the conjugate.
Ooh.
I could, but not going to help me.
Is the fraction
Multiply
just...
both sides by y over 2, y minus 2.
Yes, multiply both sides by y minus 2. So if I do that, I have x times y minus 2 is equal to y plus 3. Now, I would probably typically go ahead and distribute this. I'm just showing what happened here. So this would be xy minus 2x equals y plus 3. Now, any ideas?
We're trying to get y by itself?
Yep.
Subtract 3. Oh no, divide both sides by y.
No.
Subtract 3 first, and
Okay, after you subtract 3, then what are you going to do?
you have to divide. No.
So I typically get what I'm solving for on the left, so I need all my y's on the left.
Subtract y.
So I would move this over here, and I would move this over here. Okay, obviously those things can't
Why
combine,
are
but
there now 2 x's?
I distributed.
Okay.
So I would subtract this y over here, so I get xy minus y. I would add this 2x over here, so then is equal to 2x plus 3. Because now I have all my y's on one side, everything else that doesn't have a y on the other side. Now I can do what Zach wanted me to do to start with.
Oh, factor out a y.
I can now factor out a y. So I have y times x minus 1 equals 2x plus 3. Now what?
Move that. Divide by x minus 1.
Yep, so y is equal to 2x plus 3 over x minus 1. So this is my inverse,
Yay.
okay? So I'm pretty much telling you you're going to have one that's a fraction, because you should be capable of dealing with that. Those of you that had me for college algebra last year had one very similar to this on a quiz or a test. All right, so I'm going to check this one because this one's a little bit more, I don't know, complicated is the right word. No, I guess it is. Complicated to check, but it still works the exact same way, so I want to show you. Do you want to plug the inverse into the original or the original into the inverse?
The original into the inverse.
Okay. So I've got 2x, oh, well.
Oh, is this the fraction and the fraction and the fraction?
Yep, so I've got 2 times, there's an x, so I'm going to put this whole thing in here. So 2 times x plus 3 over x minus 2 plus 3 over x plus 3 over x minus 2 and then minus 1. All right, just to save me a step of writing so I don't have to rewrite the entire thing yet. I'm going to multiply this 2 by x and 3 inside of here so I can get rid of that and not have to then distribute again and write everything all over again.
Wait, and the bottom too, right?
No, the 2 is only being multiplied by this fraction. So it only gets multiplied by the top. So this is going to become
Top 2 fraction.
the top of this fraction right here. It's distributed. So 2x plus, 6, yeah, there was a 3 there, right? Like before I did it.
Why would it not go into the bottom? Oh, because it's 2 over 1.
Because 2 times 3/4 is, well, this isn't a good one. Let me do this. 3/5 would be
6 over 5.
6 over 5. So for the same reason as this, same thing happens up here.
I just forgot my rules for a second.
All right, now at this point, any idea what I might need to do?
You need to multiply by the conjugate.
Nope.
To which one?
Huh?
To the x.
No, to which one? We were both talking at the same time.
I only heard what he said.
Okay.
Not the conjugate.
Are we going to put the constant? No, you can't do that because it's being subtracted.
How do I combine two things where one's a fraction and one's not, or I have a
Multiply.
common denominator? I need a common denominator. What's my common denominator?
X minus 2.
X minus 2. Now, I only technically need a common denominator across the top. That they're going to have one, and then the bottom's going to have one. In this particular problem, they both have the same common denominator. Yes.
They had the same, so we would just do nothing.
What?
When we say
That's a valid question.
I don't see a denominator over here, and I don't see a denominator over here.
So we need to get a.
I thought the denominator was 1.
I thought the denominator
Well, it is.
negative 1 because it's on the bottom.
What? I'm getting a common denominator up here.
The whole thing.
To add those things together, they both have to be
Oh,
fractions.
okay.
To add these or subtract these, they both have to be fractions. So I'm going to multiply this by x minus 2 over x minus 2. And I'm doing the same thing down here. But what I was trying to point out was that it doesn't always happen that these are the same. So your common denominator needs to be one on the top and one on the bottom. They just happen to both have the same denominator, so they're going to both, or everything's being multiplied by x minus 2 over x minus 2. Okay? So, on top, I'm going to end up with, I'm going to do this. I'm going to have a big fraction. 2x plus 6. I'm going to distribute plus 3x minus 6 over x minus 2. So I've already combined my fractions here as I did the common denominator part. I'm going to do the same thing on the bottom. I'm going to have a little fraction inside the big fraction. So I've got x plus 3 minus x plus 2, yep, over x minus 2. I would simplify at this point if I can, which I can. So I have a 6 up here and a negative 6. Those things cancel with each other. So the top of this is just 5x now. So I can just cross that out. So I'm just simplifying it here so I don't have to rewrite everything over and over again. On the bottom, I have an x and a negative x. Those things cancel. And then I have a 3 plus 2, so that leaves me with 5. So what I now have left over here is 5x over x minus 2 all over 5 over x minus 2. How do I do a fraction divided by a fraction, Shepard?
Keep, change, flip.
Keep, change, flip. So I end up with 5x over x minus 2 on top times, flip this over, x minus 2 over 5.
Cross multiply.
No. Cross multiply something else. That's if they're equal to each other. We cross multiply.
Take out.
Like if this was equal to this, then I
say
cross
anything because I don't know what I said.
I think I know what you meant to say, but that's not what the word you used was for.
Cross.
X minus 2's cancel, 5's cancel, and I'm left with just an x, which means that these are inverses of each other.
Reduce, not cross multiply.
I meant to cross reduce, not cross multiply.
So,
That was only one
I'll say it again. I would strongly encourage that you check these problems, especially these ones that are fractions, because people get these wrong most of the time. Okay? So I would strongly encourage when you're doing them that you do that. Not wrong if you don't, unless I tell you to check or to verify, but strongly encourage it so you don't get the problem wrong.
Can't reach.
Okay,
You can use your stream to put your
back to one that's a little easier. 18. F of x equals the square root of x plus 2.
Barely any.
What do you mean I'm overreacting?
All right, what's my first step?
Change the x and y.
Yep, swap x and y. So I have x equals the square root of y plus 2. Now what?
Squares.
Square both sides, so x squared equals y plus 2. Now what?
Subtract it.
Yep, so y equals x squared minus 2. And that would be my inverse.
I'm good at this.
This was really
No, I'm not going to check this one for the sake of time. This one would be very easy to check. Do we need to see another one or are we good?
I think
we're
I'm really,
good.
really good.
Okay. Next thing.
Oh. I thought that was
No. We're almost there. Not quite. Confirm that f and g are inverses by showing that f of g of x is equal to x and g of f of x is equal to x. So that's basically just the... Look, it sounds complicated. It's just the check part of these problems. They're giving you the function and its inverse. All you're having to do is plug them into each other and show that they're equal to x. And it says you have to show it both ways, so you have to show it both ways if you want all the points, okay? So, 28. F of x is equal to x plus 3 over 4. G of x is equal to 4x minus 3.
Yes, it is.
All right, so first I'm going to do f of g of x. That means I'm taking g of x and I'm plugging it into x and f of x. So this is going to be 4x minus 3. Now over here, plus 3 over 4. Negative 3 and positive 3 cancel. I'm left with 4x over 4. 4's cancel. I'm equal to x. So I'm good there.
Yeah. And then now G of f of x.
g of f of x. We're taking this and plugging it in. So this is 4 times x plus 3 over 4 minus 3. So 4's cancel. I'm left with x plus 3 minus 3, positive 3, negative 3 equals x in there.
Nice.
If f of x is y, is g of x x?
No.
G of x is y.
All functions are y.
G of S.
I feel like you don't.
I got
Okay.
AirPods.
Who did it?
My mom was gonna hear that again.
AirPods.
Did you get an iPhone to go with them?
What?
Thank you. My day.
No, I mean, like, do they actually work with your
Next
phone?
problem.
They do, because it's just Bluetooth.
Okay.
I was feeling good about math. I was getting
You are doing good at math. I
Never
just
mind.
asked a question about your AirPods. You seemed very excited to share that you had
Number 30,
AirPods,
number 30.
so.
Have you told Mrs. Dutcher yet?
Yeah,
She says they connect to your droid.
They work with the droid.
These feel really
How are you still laughing? It's not that funny. It's not that funny.
F of g of x.
iPhone to go with it?
I would never have known had it not been a huge discussion last week.
I love watching
I really
this
thought he had an
video.
iPhone until like a few days ago, so.
It's the same thing.
They are the same thing.
So,
But just because two functions are the same doesn't always mean they're
Why are you
inverses.
still laughing?
It's a fraction and a fraction.
So 7 over x. Something divided by a fraction, we
Keep changing flip.
keep change flip. 7 times x over 7 is x. Now, is it going to change when I do g of f of x?
No.
No.
So just write same as above. Okay, if they are identical, you obviously don't need to show them both ways, but you do need to at least state that it's the same, so I don't think that you just skip doing it. Okay? All right, now the one where you're going to hate me. 32. F of x is equal to x plus 3 over x minus 2. And g of x is equal to... Is this the exact same problem we did earlier? Hold, please.
Yes, it is.
Yeah. So we already hate you. So we.
So we're not doing that again. I'm going to change this to something else. Hold on. I got to find another one. Maybe.
Not laughing at your shoe.
All right. We're going to modify this. This is not 32 anymore. This is just an example. Okay. F of x is going to be x over x plus 1. And g of x is going to be x over 1 minus x.
Be quiet.
All right. F of g of x. Taking this and plugging it in over here for x. So I have x over 1 minus x all over x over 1 minus x plus 1. So what's the first thing I'm going to need to do? Common denominator, which is
Where did you
1 minus x.
1 minus x.
Where'd you get the positive one? From there. Okay. And it's F.
This was plugged in for here.
Oh, okay. Yeah, I see
Alright, so on top I have x over 1 minus x. On the bottom I have x plus 1 minus x over 1 minus x. So my x and negative x cancel. Fraction divided by a fraction. Keep, change, flip. X over 1 minus x times 1 minus x over 1. 1 minus x is cancel, and I'm left with x.
Sure.
Alright, I want you guys to try the other direction on your own. So do g of f of x, try that one, and
Can you
then
substitute it for the denominator? Why not the x in the numerator?
I did it in both. Did it up here,
Oh,
which
you
was replacing this one, and then I did it down here, which was replacing this x. That's
why
what.
I got it. Okay, thank you.
Alright, take a minute and do this one.
This one. Nice.
Yes. Yep.
Maze restroom.
Did we get x?
Yes.
So there's mine all plugged in. But yes, if you did it right, you should get x. Also, just because some people think that like I don't look at their work, if your work doesn't make sense for you to have gotten to x and you just write it's equal to x, because I've had people do that before, you don't get the points. Like your math needs to actually align to get equal to x. Okay, now you may not have every single step that I do, you may have more steps than I do, whatever, that's fine, but it needs to make sense that you get down to x. Like my favorite is when they start out with this and they're like equals x. I'm like, no. Like, no way. Questions, comments, or concerns?
Is that all the problems?
Huh?
Is that all the problems?
Yep. There's your homework.